Good morning again. Our next section is going to be section 1.2. And section 1.2 goes over real numbers. And there are many kind of numbers, but the ones that we're going to be focusing on are real numbers. There are also imaginary numbers. We're not going to focus on imaginary numbers at all. We're just going to concentrate on real numbers. So the first thing that we're going to kind of cover, and everybody should be somewhat familiar with this, is the number line. And with the number line, it's just drawn out generally with a 0 represented in the middle. Every number to the right would be a positive number. Every number to the left would be a negative number. Now, we probably used those before for different things, but the key to remember is if I take a number, for an example, and I say 2 minus 4, anytime a number doesn't have a sign in front of it, it is implied to be positive. So if I'm trying to figure out 2 minus 4, I can do the number line, 1, 2, and then subtraction tells me to go to the left, so I go back 1, 2, 3, 4. Well, that puts me at negative 2, and of course that is the correct answer. If you'd rather not jump around on a number line, there are also these ways of working it out. So I'm just going to write 3 questions, or 4 rather. They're all going to be the same numbers, but they're just going to have different signs. And the key to remember with this is, and this is any addition and subtraction, if I have different, and the different ones is a negative and a positive and a negative and a positive. So the first thing I want to check is my signs. So I'm going to check my signs. If my signs match, then I always add the numbers. If they do not match or you have no match, then you always subtract the numbers. That's not anything, that's always the case. So in this case, these match, these do not match, so I'm going to subtract. 5 minus 3 is 2. For this one, they match. I'm going to add them. 5 plus 3 is 8. For this one, they do not match. I already know that 5 minus 3 is 2. And for the last one, they match. So once again, I'm going to add them together in 8. Now remember, there's 2 parts. The first one is just determining the signs. The second one is determining the signs that go in front of the numbers. For that, all you have to do is always choose the larger number. The larger number dictates. For this example, 5 is bigger than 3. 5 is a negative number, so this answer is going to be negative 2. In this one, 5 is a larger number. It's a positive, so it's going to be a positive 8. You do not have to put positives in front of your answers. I just put them in to kind of show you an example. For the next one, once again, 5 is a bigger number. It's a positive, so this one will be positive 2. And for the last one, 5 is a larger number. It's a negative, so this is going to be negative 8. Notice how all I've done is move these signs around in my equation or in my problems, but I've come up with 4 different answers. So the next thing that we're going to go over is fractions. And when people see fractions, they start, thinking, oh, that's hard, I can't do them. Don't think of it that way. This is just my fraction, a over b. In this case, always, well, not in just this case, but always. The top is always the numerator. The bottom is always the denominator. And remember, in math, you can always multiply anything, but you can only add like items. So in order to add fractions, you have to have the same denominator. That makes them the same. You can always multiply any fractions, however. Now, we can reduce fractions and we can enlarge them, but for this class, for the first part of it, I don't want you to reduce any fractions. Whatever the number comes up with, the number comes up with. So for example, if we have, let's just say 1/5 plus 2/5, well, let's go with 10. Let's say 2/10 plus 2/10. If this is going to be our problems, remember, I'm kind of jumping ahead, but this is going to give me 4/10. Now that can be reduced to 2/5, but I don't want you to do that for the first part of this class. I just want you to leave it at 4/10, and then we'll move on from there. If we multiply these, for an example, 2/10 times 2/10, I always multiply straight across. And remember, we really don't divide fractions, we multiply them. Technically we do, but we're really multiplying them. 2 times 2 is 4, 10 times 10 is 100. I can reduce that to 1 over 25, but once again, for the beginning of this class, I just want you to come up with the correct answer. Next thing that we're going to cover is the absolute value. And the absolute value is important because there are certain things that go to zero. So for an example, if you think of a temperature gauge has a 0, but you also have temperatures below 0 and you have temperatures above 0. So let's say for an example, the temperature today is 70 degrees, and let's say the temperature in Antarctica is negative 40 degrees. If we were trying to see the difference between these two, we just wouldn't write the problem as 40 minus or 70 minus 40, because that would just give you 30. But the difference between 70 and 0 is 70. And then I add that to the difference between 0 and negative 40, which is 40. So the difference between these two temperatures would be 110 degrees. Now, other things that can have an actual are sea level. So sea level is set at 0. Airplanes flying in the air are above ground level. Submarines and things, whales and that type of stuff. If I can draw my submarine, that's supposed to be a submarine, could be a whale too. But anyway, those would be below sea level. Now, the way you represent absolute values is with two straight lines. We don't focus a lot on absolute values written this way. We focus more on them in the problems. But anyway, an absolute value is always positive. So in this case, the absolute value of 5 is 5. It's just the distance of how far it is from 0. So 5 is 5 spaces from 0. Just like negative 5 has the same absolute value. Because they're always positive, all you do is drop the negative sign. Once again, negative 5 is 5 spaces from 0. Hence, the absolute value of it is 5. And the absolute value is never negative. It's always positive. Or if you use 0, it could be 0. So we also have opposites, and what opposites do is it allows us to solve certain things. So for example, every number has an opposite. So the opposite of negative 3 is just a positive 3. The opposite of negative 1/2 is positive 1/2. The opposite of positive 8 is just negative 8. So basically all you were doing is reversing the sign. And it's important to use because when we start solving equations, then that's what we're going to be using are the opposites. Now, next thing we're going to cover is multiplying fractions, and I kind of just briefly reviewed that. But anytime you multiply fractions, like I said, we don't have to reduce them in this class yet. We will get to that point. If I want to multiply 3/5 times 1/4, once again, I just multiply straight across. Whatever I do on the top, do on the bottom. You'll hear that over and over in this class. 3 times 1 is just going to give me 3. 4 times 5 is going to be 20. Even though we can't reduce this one, if we could, I wouldn't want you to, and just circle it and then move on to the next one. Once again, if I use another one, so let's say I'm going to do 3/5 times 2/4. Once again, I'm just going to multiply straight across. 3 times 2 is 6. 5 times 4 is 20. Like I said, even though I can reduce that one, I don't need to at the beginning of this class. Now, I told you that you would see the perimeter and the area on every exam or test that you take in here. You also see this, the reciprocal. And the reason being is the reciprocal is important, not just in this class, but with everything you solve moving forward in your science classes, any type of stats classes. So basically all a reciprocal is, it is two numbers, or it's the leftover of two numbers basically, whose product, and product means when you multiply something, it's two numbers whose product is 1. So for an example, if I have a 3, the reciprocal of 3 would be 1/3. So any number divided by 1 is itself. All you're basically doing is flipping this number upside down. Get it on the screen a little better. There we go. I'm just flipping that upside down. And if I multiply straight across, once again, I'm just going to put these in parentheses to tell me that I'm going to multiply. 3 times 3 is 3. 3 times 1 is 3. Once again, same thing. 3 over 3. Any number divided by itself is going to be equal to 1. So the reciprocal is always flipping something upside down. So if I just had a regular fraction, such as 2/5, I'm flipping it upside down. The reciprocal of 2/5 would be 5/2. Now it's important to note if the reciprocal is negative, so for an example, negative 2 over 1/2, then your reciprocal is also going to be that way, which will be negative 2 over 1, or the same thing as 2. Both of these answers are acceptable in my class. Whichever one you choose is entirely up to you.